Okay, so I'm trying to do 11.115, which is sketch this exponential function. We haven't talked about these, right? So this is our first encounter with trying to draw an exponential function. So how do we draw functions we're not sure of?
What if you can't draw?
It's okay, it's just a sketch. It can be bad.
Make your graph.
So I would like to, all right, make some axes. Okay, so there's some axes. Now, how do I know what points to put on the axes?
They're giving them to you.
No, they're not.
Oh. It's complete each table of values.
Yeah, it says complete each table, right?
Right.
So they gave me one of these f of x tables.
-2, -1.
And then they gave me my 5 favorite points, right? Okay, so I need to fill in the f of x's. Remember, this is actually how we usually graph things we don't know about, right? We make a little table, we fill in our 5 favorite x's, and then we try to plug it in and see if we can connect the dots, right? This is not the best graphing method, right? But it's the one we use. So, okay, one of these is easy. Which one's easy? 0. When I plug in x is 0, I get 2/3 to the 0, right? What's stuff to the 0? 1. Oh. Okay, that was easy, right? You guys cool with that? Yeah, the first power is also easy because 2/3 to the 1 is just 2/3, right? Okay, so I got 2/3 out of that. Which one's easy? 2, probably. Okay, so I've got 2/3 to the 2. What's that? 4/9. I'm just multiplying it by itself, right? Okay, so I got 4/9. All right, how about the negatives? What are those going to do?
Mess things up.
This is going to flip it over, right? So I've got 2/3 to the -1. That's
3/2.
3/2. Just flip it over. Okay. How about 2/3 to the -2?
Oh, would it be like what?
I should flip it over and then square it, or square it and then flip it over, right? Doesn't matter which order you do. So I'd say let's flip it over first. So we get 3/2 squared. And then that's 9/4. Okay, so I got my points. Now I should try to graph. So we see, it looks like I've got not such a big graph to draw, right? I just need like 2 ticks in each direction. Yep. Sort of shorted myself there. Okay, so where do my dots go? Where's the easy dot on this?
0, 1.
0, 1, that's where? Which axis is that on?
On the Y.
On the y?
0.
So that's this point, 0, 1.
How would you do the other one, so if it's not like an exact?
Yeah, so if they're not exact, I have to kind of think about it, right? Okay, so this one's supposed to be where?
2/3.
2.
So it's
1 over
1 over and then 2/3 up. Okay, so 1 over I can do, right? It's just a sketch though, so 2/3 up, you go, 2/3 up. Right, it's just a sketch.
Okay.
Okay, so that's 1 and 2/3. Okay, so there's my dot for that one. All right, how about 2 and 4/9? So over 2 I still understand, right? How big is 4/9?
Almost. It's small.
It's pretty small. How big? About
Less than a half. Little less than a
Yeah, it's just a little under a half, right? A half would be 4.5 nines, right? You guys see that? Okay, so we're going to about halfway up and then maybe just down a little tiny bit. Because a half a nine is not very much, right? Okay, so that's those ones. How about on the other side?
Go -1 and 1.5.
Okay, so this is 1.5, right? So I go back 1, up 1.5, puts me in about here. So that's -1, 3/2. Forgot to label this guy. That's 2 and 4 9. Okay, how about the other one?
-2.
And 9/4. Okay, so -2 I get.
-2, and then up 2.
Yeah, 9/4 is 2 1/4. So I should go to -2 and then up 2 and maybe another bit. So I'm thinking about there. Does that look okay to you guys? So that's -2 and 9/4. Oh, this is kind of a crummy looking picture, right? These all look like they're almost on a line, yeah?
It's like,
Yeah, they're like just a little bit off of a line. What should I do to get a better picture?
Make it
Connect
line.
them.
Yeah, I'd like to connect them, right? But to get a better idea of what this function looks like, what should I do? Maybe get a couple more.
Different distance.
Yeah.
Use the calculator.
Yeah, we could use a calculator, that'd help. I would say if I want a better picture, I should get a couple more points. So let's plug in 3 and -3, right? Just to get one more set of points on this. So if I plug in 3, what do I get out? Say that louder. 8/27. Oops, sloppy 8. Thanks, Rebecca. So I got 8/27. So if I'm going to put that one on the picture, that's 3. How big is 8/27?
It's incredibly small.
Pretty little.
A little less.
It's a little under a third. So these are getting small quick, right? Okay, and -3. What do I get there?
27.
Yeah, that one's easy, right? I just flip the one for 3 over. So I get 27/8. How big's that?
3.
A little over 3.
Yeah, this one was a little under a third, right? If I flip it over, I'm going to get a little over 3.
3
See that? So I need another tick mark and another tick mark. And I'm looking for something like up here. You guys see that?
So we have a perfect.
Yeah, that gives me a little better perspective, right? This thing is a little more bent than I originally thought. So if I was going to graph this, I'd kind of connect the dots, right? So these guys are going to go over that way. Are they ever going to cross the x-axis?
No,
Why not?
they would have crossed at 0.
Maybe.
Why wouldn't
Why wouldn't they cross?
It's just gonna keep getting smaller and smaller.
It's not a
Figure out.
graph.
So what am I doing? I'm thinking about raising 2/3 top bigger and bigger powers as I go that way, right? If I multiply a bunch of 2/3 together, is it ever going to be negative? No, there's no way, right? In fact, it can't even actually be 0. You guys see that?
Would it just be infinitely tiny?
It's going to get really, really little, right? Because lots and lots of things smaller than 1 multiplied together are going to be really little. But it's never actually going to get to 0 because there's still going to be something left, right? Is that you're taking 2/3 each time you go out a unit of what was left.
So
That's cool.
why would never get to 0 again?
Every unit tick is taking 2/3 of what there was before, right?
Uh-huh.
So if we take 2/3 away, there's still something left. And then we take 2/3 of that away, there's still something left. If we take 2/3 of that away, there's still something left.
Is
Guys
this
see
seen
that?
as paradox?
No. This is math, not reality, right? So I don't have to worry about splitting it into atoms and things.
If you only have two, you're gonna run out.
Every time you take 2/3, not of what you started with, but of what you had at the previous step. Does that make sense? So there's always some little bit left over. It's going to get really small, which is why we're doing something like this. We're saying these guys go this way and get really little. You guys see that's an asymptote? From the section on rational functions, there was this thing called an
Yeah, I know, but
asymptote.
how does it gonna be the vertical? Which one is the?
It's not vertical. So this is kind of a sideways asymptote. Right? If I cocked my head at it this way, it would look like an asymptote.
So where's gonna be the break?
Is it this way? It doesn't hit 0.
Oh, my.
So going backwards, right, what happens? Well, these guys get bigger fast, right? Because I flip it over and then multiply a bunch of them together. If I flip it over, I've got 1.5. I multiply 1.5 together, it gets bigger by 50% every time. You guys see that? So I've got this kind of shape. This is what all the exponential functions look like. So this one was f of x is 2/3 to the x. You see that?
Anything that looks like that formula is gonna be that type of. And
Almost.
if it's negative, then it will just go the other way, right?
Almost. So this is f of x is ax, where a is smaller than 1 and bigger than 0. So these guys all kind of look roughly like this. You can see that. The point labels are wrong for these, right? Because I made the point labels with 2/3. If I made them with A, they'd look a little bit different, except for that one.
It's always 0, 1. It's always, the intersection's always at 0, 1.
Yeah, why is this point 0, 1 always on there? I claimed that just now, and Sandy noticed it in the problems too.
No, that means it's always 0, 1.
Yeah, so why is 0, 1 always on there? Because whatever to the 0 is 1, right? So when I've got one of these functions that looks like something to the x, when I plug 0 in for x, it doesn't really matter what the something is. You guys see that? Unless it's 0. That one's weird. We avoid that one like the plague. So let's not talk about that one.
And then also the reason it doesn't hit the line is because even negative exponents it's flipped around to make them positive, right?
Yeah. You guys see that? Questions on this? Okay, how about this? If I was going to graph f of x is ax for a bigger than 1, what would that look like?
Oh, you start with 1.
Okay, so it starts here at 0, 1, right? You guys see that? And now when I multiply more and more of these guys together, these get big, right? You guys see that? When I flip it over and multiply more and more of them together, it gets small. So I get this same picture, just reverse. Does that make sense? Cool. Should try some of these and see if you can get one of these out of the problems. So it'd be good practice.